Welcome to Differential Equations, Section 2, Chapter 1. In this one, we will actually be finding the solutions of some various problems. So in the past video, we actually had the original equation f equals ma for a following object. And then we actually derived this equation, dv dt, to find the maximum velocity of this following object. We had these constants, which makes this problem solvable. So in this case, we're actually trying to find v of t. So we'll actually keep dv dt the same on this side, and we'll take out this 1/5. So that's going to make it, so 9.8 times 5 is going to be 49 minus v. We'll actually make this a negative, so we'll take the negative out to make the v positive. So we have dv dt is equal to negative 1/5 times v minus 49. We're going to move this over to the left side through division. So we're going to have dv dt is equal to v minus 49, which is equal to negative 1/5. We're going to move this dt over to the right through multiplication. So we're going to have dv over v minus 49 is equal to negative 1/5 dt. So now that we got this separated, so the v's are on one side with the dv, and then the t is with the constant, and in this case we don't have any t's. If there was, we would want it with them. We can integrate both sides. And we know this is a natural log function because it's 1 over v minus a constant, and it's, yeah, you should know that from Calculus 1 or Calculus 2. So we'll actually have the ln of this, v minus 49, and that is going to be equal to negative 1/5 t plus c. And then we'll get this in a more standard form. So we'll have e to this function, e to this function to cancel out the ln. So we'll have v minus 49 is equal to, and remember e to the c is just some constant, so we'll pull that out. C e to the negative 1/5 t. We'll actually move the 49 over, so we have the final function v of t is equal to c e to the negative 1/5 t plus 49. The other example we have is this population function. So we have dp dt, so the derivative of population with respect to time is equal to 0.5 p minus 450. Once again, we're trying to find p of t. So we'll try to separate the variable p with dp and then get the dt with just the constants. So we're actually going to multiply, because this is p over 2, we're going to multiply this by 2 to get it all underneath the same denominator. So this goes to dp dt is equal to p minus 900 all over 2. Or we could factor that out as a 1/2. So next we want to get the p minus 900 over to the left side. So we'll actually just divide that. So we've got dp dt is over p minus 900, which is equal to 1/2. Same thing, we're going to multiply the dt over to this side, which goes to dp over p minus 900 is equal to 1/2 dt. So we have the constant separated with dt, the p minus 900 with the dp, integrate both sides. This is going to a natural log function again. So we'll have natural log of p minus 900 is equal to 1/2 t. E to the ln of p minus 900, and then e to the 1/2 t. So the e and the ln cancel, so we'll actually have p minus 900, which is equal to, oh, forgot the c, c e to the 1/2 t. And remember, the c, e to the c is just a constant, so we can pull that out. And lastly, we can just have P of t, which is equal to CE to the 1/2 t plus 900.